In 26 to 30, we're going to actually find some measurements of a rhombus. And this particular rhombus is called math. And it has some initial information. AM's 12, measure of angle 1's 25 degrees, MT and AH are diagonals. And we need to find all the measures it gave. And also, because we can, we're going to do a bonus problem as well. We're going to try to find the length of the diagonal MT here. So first up in a rhombus, I'm not even going to try to write things in the lines quite yet, but because it's a rhombus, we know a couple things. First, every single side has to be the same. So I'm going to fill in a bunch of 12s, because we know the top's 12, so is every other side. Also, what we know is that the vertex angles are bisected by the diagonals. If angle 1 is 25 degrees, so is angle 2. And then over at vertex angle A, those two angles also have to be 25s. They're alternate interior angles to the ones at vertex angle H. So we begin with that kind of information, and in addition, we know that in a rhombus, all of the central angles are right angles because the diagonals are perpendicular to one another. So given this information, we can pretty much fill in all of these blanks. In fact, we might be able to fill in all of the blanks. We know angle 2 is 25 degrees. Measure of angle HMA has to be supplementary to the 50 degrees that vertex angle H is. Supplementary to 50 degrees is going to be 130 degrees. Measure of angle 3 is going to be 90 degrees because all those are right angles at the center. AT, we just filled in as 12, and so is TH. Well, our bonus question for the day is going to be MT equals what? That's the diagonal between the vertex angles M and T. Well, that might be a little bit harder, but we can figure out this. We can figure out what half of that diagonal is because we can use some right triangle trigonometry. These right triangle trig style problems pop up a lot in rhombuses because you've got those right angles to work with. I'm going to start by redrawing the triangle in the top. That is triangle M3, I guess, to the center angle A. And it looks like this. Our angle X is going to be on the, side X is going to be on the left side. We know the hypotenuse is equal to 12 because it's labeled in green up there. And then 25 degrees is going to be, it's going to be our reference angle here, actually, when we set this up. So we want to use SOHCAHTOA. And what we have on hand is the opposite side to our reference angle, 25. The opposite will be X, and the hypotenuse will be 12. We can say sine of 25 degrees is equal to X over 12. And just to simplify things a little bit, I'm going to instantly multiply both sides by 12 even before jumping into my calculator. So 12 times sine of 25 is going to be our missing value X. So I'm going to go into my graphing calculator. I'm going to use Desmos as usual here. I'm going to type out 12 times, I got to be really sure to use degree mode. It defaults to radians, selecting degrees, and I'll type out sine 25. And it tells us that that is 5.071. That's the value of X. But MT is twice X. And if we double that value, we're going to get 10 and I'm trying to do this in my head, 142. And it might actually, in reality, round up to 3 because of how we had rounded the trig function. But I'm not too concerned about that difference of 1,000th. That's not really that big of a deal. So that whole diagonal is equal to 10.142.